Hello, everybody. Today we'll be presenting our machine learning project. So our title is Assessing Player Attributes, Predicting Soccer Match Outcomes. The members of our group include me, Jeffrey Lee, Claude Hu, and Randy Shi. So in our study, we'll be using the Kaggle European Soccer Database, which is an SQL database containing information on scores, lineups, team formations, betting odds, and many more.
In this project, we're solely studying the English Premier League. The objective of our research is to predict the outcome of matches through the assessment of players' performance indicators. In the KES database, performance indicators are represented through 33 variables, which details players' performance on a 1 to 100 scale regarding different abilities. For instance, a player with good free kick abilities will score relatively high on the free kick accuracy category. We intend to analyze the data along with match results in terms of goals scored, wins, losses for the 2009 to 2010 to 2015 to 2016 Premier League seasons.
We proposed naive Bayes and logistic regression as the machine learning techniques we were going to use to assess the data. Both methods fall into the category of classifiers, with naive Bayes being generative and the logistic regression being discriminative. We thought it would be appropriate to incorporate naive Bayes since we can find the probability of an event A happening given that an event B has occurred.
On the other hand, logistic regression makes predictions based on whether an observation falls into one of two categories of a binary dependent variable. From logistic regression, we can describe the relationship between the dependent variable outcome and the multiple ordinal independent variables.
Since the recording of this video, we have completed data processing and performed one task using logistic regression. The steps we have taken so far are establish a database connection to the SQLite Kaggle database, so we can access and read the data in Python. Explored and extracted relevant data pertaining from the Premier League from the Kaggle dataset to generate 4 separate data frames focusing on player data, which associated an identification number with a player name. Player attributes data, which contain the different attributes for all players, including overall, current, and potential ratings. Team data, which listed out the English teams. Match data, which presented data on match results, player lineup, and goals scored by home and away teams.
We've also generated features from the player attributes data and match data. We decided for our first rounds of testing to use overall player ratings rather than individual performance indicators because it is simpler and we can provide working models and results for this video. In a game of soccer, there are 11 players on each team and therefore 22 players in a game total. Our features reflect this as each match is associated with 22 total player ratings from both home and away sides. Additionally, we also generated labels from the match results from match data. We created 2 labels, win and no win. Win is determined if the home team scores more goals than the away team. No win is determined if both teams score the same number of goals or if the away team scores more goals.
Here's a bar plot showing home players' average ratings grouped by labels, which are wins and no wins. And we can see that the ratings for winning teams are higher than the ratings for losing or drawing teams. The little black lines on the plot are error bars, and we can see that the variance is very small.
We've also performed 10-fold cross-validation as a method of pre-processing, and also performed a logistic regression for our first model test. We compared the accuracy results with training and test set using an accuracy score function. The score of logistic regression for training set was 0.65, while the score of logistic regression for the test set was 0.55.
So for future steps, we will first try different features. There are lots of unused features, and we will select and generate new features based on instinct or common sense. Also, we will try different pre-processing methods like PCA, LDA, or different values for K-fold, cross-validation, and some other methods. Finally, we will test different models. Right now, we only have results for logistic regression, and it's already better than random guessing.